All right, so section 1.6, and first thing I'm going to do is I'm going to draw a picture. Pretty picture. Now watch what I'm going to do. This picture is going to be drawn of all line segments. All right? Everybody awake now? Get him. All right, so watch. This picture I'm going to draw is all made up of line segments, and watch. Each line segment is attached to the other one at their endpoints. Do you see that? See, I'm taking each endpoint and I'm attaching it. Does that make sense? And let's go up like this. I just drew some random shape. All right. How many sides are there? 1, 2, 3, 4. There's 5 sides. Okay. And yeah, that's what we're going to call this. So I said this is basically learning a bunch of vocabulary. So the first word is a polygon. All right. You probably know what that prefix poly means, don't you? Well, just bear with me. We'll get to it. Okay, what's the prefix poly mean? Many. It means many. Doesn't mean 5. It means many. All right? And gon is talking about the angles. Okay, so it means many angles, technically. But let's get a little more specific. Notice what I said. Each of these line segments are attached at their endpoints. Do you see it? Would you agree? Every single line segment on this thing is attached to another line segment at their endpoints. And it's closed in. There's no gaps. There's no overlapping or anything like that. So we call this thing a polygon. It means many angles. So that's what makes it a polygon. Let me give you an example of something that may not be a polygon. Let's just do this real quick. And like that. Okay. That right there is not a polygon. Why is this not a polygon? It's got straight sides. They're all attached. It's not closed off. That's right. See, the end of this line segment right here is not attached to the end of another line segment, is it? You got this big gap right there. So this is not a polygon. This one is. This one's not. You with me on that? All right. Pretty easy to see. This one also has a special... let's do this. Let's talk about the line segments themselves. We give them names. We call them the sides of the polygon. All right. So each of the line segments. So how many sides are there to this particular one? 5. Right. This is not the only type of polygon. I just drew some random polygon. All right, it happens to be 5 sides. Didn't have to be 5 sides. I just drew it that way. All right. Now look, each of these endpoints are joined, right, to the other endpoint of this. See, this endpoint of this segment is joined to the endpoint of this segment right there, and it happens all throughout this polygon. What do you think we call that? It's a vertex. That's right. This point where it's attached is called the vertex. We've talked about the vertex of an angle. Well, that's the vertex of a polygon. Forms an angle, though, doesn't it? You see it? Forms an angle, so that's a vertex and that's a side. By the way, we call this a convex polygon. Let me do something real quick for you. I'm going to take each of the sides. What if I was to extend each of these sides? I'm going to do it in a different color, and I'm going to do it as a dotted line. All right, if I took this side and extended out here, and I extended this right here, and then I did it to this, I'll just do this real quick, and I extended this one out. Take this side right here, extend that side. What I'm looking for is those extensions, those dotted red lines. Where are they intersecting, or where do they hit? Inside or outside the polygon? Inside? Yeah. I mean, this is inside. Do those red dots even go inside there at all? No, they don't. All these red dots are on the exterior, right? Outside, the exterior. So in order for it to be a convex polygon, if I took each of the sides and extended them out, they'll all be on the outside of the polygon. They'll never go inside the polygon. Does that make sense? You guys taking notes? Okay, Javon? You got to wake up, man. All right? Take notes. That'll help you stay awake. All right? Write some stuff down. Write some stuff down. Everybody should be taking notes on this. All right, so all these dotted lines are on the outside of this polygon. So that means it's a convex polygon. Well, there's another type of polygon. I'll tell you what, let me just play around. Let me make this into a polygon. That's not a polygon right now, is it? Let's just do this. We'll make it into a polygon. All right, is that a polygon now? Yeah, everything's attached to the ends, okay? That one looks like it overlaps a little bit, but I was just off a little bit. Just pretend it hits right there, okay? So yeah, that's a polygon. It's closed. There's no gaps in it. There's no overlapping. Yep, so it's a polygon. Let's do this, though. Let's do the same thing as we did before. Let's take the sides and extend them out. and see where they intersect. Okay. That's all outside, right? If I took this side, that would be all outside. Let's take this side right here and extend that one and extend this. That would be outside, but guess what? What if I took this side right here? Yeah, see, that extends out, but watch this. This one, if it keeps on going, look where it went. It went inside, didn't it? That's enough right there to say that it's not convex. It's not convex. Anybody know a word? In science class, you might have talked about glass and things like that, and lenses. D, what is that called? You got convex, and what's the other one? It's concave. Did you learn that in science class? Yeah. Okay. You probably did. And that's what this is. This is a concave. It's still a polygon, but it's a concave polygon. All right? Because it goes in. I think cave, right? What do? You go inside the cave, don't you? Look at this. The dotted lines are where? Inside the polygon. You get it? So that's concave. This is convex. They're going to ask you some questions, and they're going to give you a polygon. They're going to say, okay, tell me. Is this concave or convex? You have to look at it and be able to tell what it is. Everybody got that? All right. Enough of that. I know this is not the most exciting stuff in the world, and we're not really solving for anything. We're not finding any, missing angles or missing sides or anything. It's just vocabulary, but like I said at the very beginning, geometry has its own language, basically. And that's what we're trying to do here. We're trying to learn this language and learn what these words mean, because we're going to refer to them over and over and over again. All right, let's do this. Let's talk about the different names of different different polygons. So let's do a little column. I'm going to do a little column right here and right here. So the first column are the number of sides. In the second column, we're just going to write the name down. Okay? We have specific names for some of these polygons. On that first polygon, somebody said, that's not a polygon, that's a pentagon, right? Why'd you say pentagon? Because it's a what? 5 sides, okay? So that's what we're going to do. Each one of these has a certain name associated with it. What do you think the smallest, or the smallest number of sides that a polygon can have? 5, that's the smallest. You can't have a polygon with less than 5 sides. 2, I heard a 2. Can you have a polygon with 5 sides? Look at it, watch. Here's one side, here's another. Is there any way I can have just 2 sides and make that a closed figure? No, there's no way. 3, that's right. So if I did this, okay, but that is a polygon still, isn't it? Still a polygon. How many sides? 3. So what's the smallest number of sides that we can have? 3. All right, so there's 3 sides, and you already said it. What's the name of that? It's a triangle. All right, it's got a special name. And that's all we're doing. We're just giving special names to these. Let's go 4. Now 4, you might think, okay, a lot of people say rectangle, some people say square, okay, but is every single 4-sided figure a square? Is every 4-sided figure a rectangle? No, because watch, 1, 2, 3, 4. That's 4 sides, isn't it? And it's a polygon, but is that a rectangle? No. Is it a square? No. So we have to be more general than that, and they call it a quadrilateral. Right. Quad meaning 4, and lateral, quadrilateral. Lateral meaning what? Sides. Lateral means sides, okay? So that means 4 sides. All right, let's keep going. 5, you've already seen one, and you've already named it. And it's called a pentagon. It's a famous building in D.C., isn't there? Called the Pentagon? Sure there is, okay? And 5 sides, we'll talk more about that. Javon, you still with us? Stand up if you need to stay awake, all right? Number 6, or not number 6, but 6 sides. If you have 6 sides, right, we call it a hexagon. All right? Okay, so that's a hexagon. You ever look at a soccer ball? At least the old school soccer balls. Now the soccer balls are kind of new. They've got stitching, like all crazy designs all around it. But the old school with all little panels on it, you know what I'm talking about? Okay. If you look at it real careful, that soccer ball is made up of 2 different shapes, pentagons and hexagons. All right. The way it works out with the geometry and all the angles, you can take all the pentagons and hexagons and you can make a perfect sphere, a perfect ball out of those. You couldn't just take a whole bunch of pentagons, stitch them all together and make a ball. You couldn't take a whole bunch of hexagons, stitch them together and make a ball. The 2 together, though, a pentagon and a hexagon, actually make up that soccer ball. So if you ever see a soccer ball, if you guys are on the soccer team and you got practice today, look at some of the old school ones. I guess they still make them like that, but now the designs are a lot different than when I was a kid. When I was a kid, all the balls were either Pentagon and Hexagon, all the soccer balls anyway. All right? So anyway, 7. What about 7? We don't use this very often, but they call it a heptagon. H-E-P-T-A, hepta. And I think there are other prefixes for 7, but this is the one that they use for that. Now, an 8 is a very familiar one. What is that? Octagon, right. Okay, octa. There's no special name for that. What's that? Septagon right here. Oh, septa. Yeah, I think septa is, I think, another prefix for 7, but for some reason they use hepta on this. But I think septa is a prefix for 7, if I'm not mistaken. 9 is kind of weird. It's a non-agon. All right. 10 is one that should be familiar. 10 years is what? A decade, so these are all gone, so what do you think it's called? A decagon. Well, it's not a decade gone, but a decagon. All right, because deca is a prefix for 10. All right, 11 is really strange. I'd never heard of this before until I looked at this book. It's called a hendecagon. No idea where that comes from. Maybe it's from a Latin word or something like that. I have no idea. 12 is kind of odd too. It's kind of sounds cool though. It's a dodecagon. Dodecagon. Somebody said that sounds like a oh shoot, what's those little things? These little Japanese animated things people bought their cards on Pokemon. They said, oh, it sounds like a Pokemon. Dodecagon. Alright. And a hendecagon. Who knows? It could be. And that's all the special names. After that, they don't give them any more special names. I mean, you know, you can't go to 157 and have a special name for that one. That would be dumb, wouldn't it? So what they do is they say n means n number of sides, whatever number of sides, and they call it an n-gon. For instance, let's say there's 57 sides. So we call it a what? 57 gon, all right? It's not very creative, but it's good enough. It means angles. It's the word that it kind of comes from angles, all right? So anyway, that's what that is. Now notice all of these are still polygons. They all fall under the umbrella of a polygon because poly means what? Many, all right? And these are all many, right? Some are more than others, but polygons means many angles, and it all has to be working like this. All the sides have to match up with the other sides. You see it? No overlapping or anything like that. Let me see if there's anything else I missed. Yeah, I should have gotten to that today, but I'll leave you at the same exact spot I left the other class, and that's right here. Okay? What's that? A shout out? Yeah, Brett Netzer, sit up in your seat and quit sleeping. My goodness, and quit picking your nose too. How's that? Is that a good shout out? All right, good. All right, that's it. No homework tonight. I'll give you some tomorrow, though, once we finish the lesson, all right?